Hello and welcome students. We are doing calculus. We are doing basics of calculus for physics. Basics of calculus for physics. This is a part of mathematics which is useful for your physics. So let's begin with today's lecture. This lecture is lecture number 2. And in lecture number 1, I had covered the beginning part of it. Today we are going to take it ahead. This is lecture number 2. In last lecture number 1, I had given you the theorems on derivatives. Two theorems I had given. So today we will begin with the third theorem. So the third is product rule. We call this as product rule. If u and v, you could even write f of x and g of x. I'm writing u and v. If u and v are differentiable functions of x. Now, what is meaning of this statement? It simply means that the function u, this function u and v both can be differentiated with respect to x. That is, you can find d by dx of u and d by dx of v. Okay. So for time being, you can understand only this much from the statement. U and v are both functions of differentiable functions of x. U and v are differentiable functions of x. Further, if u and v are differentiable functions of x, then d by dx of u into v, what will this be? It will be u d by dx of v plus v d by dx of u. So what have I done? Let me explain this. See students, when you are differentiating, see we have got d by dx outside the bracket, and here we have product of two functions. Okay, u and v are multiplied. Like suppose I write sine of x, I consider u as sine of x and v as log of x. So I have d by dx of sine of x multiplied to log of x. Okay, so if I have to differentiate sine x into log x, then what would I do? Okay, so it will be sine x derivative of log x. Okay, it will be sine x derivative of log x, sine of x d by dx of log x, okay, plus log of x d by dx of sine x. So remember students, the function with which you write d by dx is differentiated. The function with which you write d by dx is differentiated. Okay, so here in the first term, you are differentiating log of x. Okay, and in the second term, you are differentiating sine of x. You can check. So log of x is differentiated, sine of x is just multiplied. Sine of x is differentiated, log of x is multiplied. So in short, what is the product rule? The product rule says that you will differentiate both the functions one by one. Both the functions will be differentiated one by one. When one of them is differentiated, the other is multiplied. And when the other is differentiated, the first one is multiplied, and then both are added. Those two terms are added. This is product rule. Okay, so here for the example, if I proceed, I will get sine x and d by dx of log x, as I've already given, this is 1 by x, and here log x, this will be cos of x. Okay, you can, students, you can have one more example here for product rule. I give you one more example for further practice. Suppose I have d by dx of x square multiplied to cosec x. Okay, so what we notice that in between x square and cosec x, it is two functions that we have here. We have two functions of x here. One is variable raised to constant x square function, and the other is trigonometric function cosec x. So we have two functions, x square and cosec x multiplied. See, in between them we have product sign. So the rule says that you differentiate both of these one by one. So suppose I differentiate cosec x first. So when cosec x will be differentiated, x square will be multiplied. So x square multiplied to d by dx of cosec x. Then you will differentiate x square and multiply cosec x. Okay, and you put a plus sign in between them. So cosec x multiplied to d by dx of x square. Very simple. Okay, so this is x square, d by dx of cosec x is minus cosec x into cot x, plus this is cosec x, and derivative of x square with respect to x is 2x. So you can take, if you want, you can take this cosec x common. So when cosec x is common, you get here minus x square multiplied to cot x plus 2x. This is the answer. Okay. This is product rule, that is d by dx of u into v. We can continue this with the product of three functions. What I mean, suppose we have d by dx of u v w. Okay, so this time we have product of three functions. Then what would we do? You saw what we did for u into v. What did we do for u into v? For u into v, we differentiated v and multiplied u. Then we differentiated u, multiplied v, and added them. This is for u into v. What we will do for UVW? We will do exactly the same. Okay, let's begin. Once again, students, we have to differentiate these three one by one. So I will begin with W. D by dx of W I write. Now students, when I differentiated W, the other two which are left, I will multiply. U into V is multiplied. Then plus, I will differentiate V this time. So when I differentiate V, the other two which are left, that is U and W, I will multiply. And finally, I will differentiate U. What are the two left? When U is differentiated, V, W are left. I will multiply. I will multiply. So if you check, this once again goes with U into V. This U, derivative of UV is same as derivative of UVW is same as derivative of U into V. Why? Because even in that case, if you remember, when you differentiated V, you can check here. When you differentiated V, U was left, so you multiplied. And when you differentiated U, V was left, so you multiplied. So in short, you can say that when you have the derivative, when you have to find the derivative of product of several functions, then you differentiate all those functions one by one. And when one of the function from those all is differentiated, the remaining rest over functions are multiplied. And this continues till you will have differentiated all the functions. Till you will have differentiated all the functions. You can have an example for this. Suppose I have d by dx of x square into log of x into sine of x. So for this, what I will write, I will begin with, see, I go from last to first. So I differentiate sine x first. So x square into log x into d by dx of sine x plus. Now I have to differentiate log x. So x square into sine x, and remember we will write plus in between every time. X square into sine x d by dx of log of x, d by dx of log of x plus log x into sine x, log of x into sine of x, and d by dx of x square, d by dx of x square. So what you have this as equal to, students? That's it. So you have x square log of x into cos x, d by dx of sine x is cos x, plus x square sine of x into 1 over x plus log of x into sine of x into 2x. This is the final answer. Okay, here 1x will cancel. This is 1 upon x. So this is x square, 1x can cancel. And this is what is the final. Okay, students, after product rule, the next one that we do is quotient rule. The next one is quotient rule or division rule. You can also call it as division rule. Now, as the name suggests, in this rule, we are going to learn how to differentiate if we have quotient of two functions. That is, one function is divided by another function, then how do we differentiate? So the statement of the theorem, if u and v are two differentiable functions of x, two differentiable functions of x, then d by dx of u upon v, d by dx of u upon v. Students, d by dx of u upon v, what does that mean? I am differentiating the division of function u with respect, I am differentiating the division of function u by v with respect to x. I am differentiating u upon v with respect to x. There is a derivation for all these theorems. We are not doing the derivation, as you know. I will write the rule only. The rule says, the theorem says, you will have numerator and denominator. In numerator, you will first write derivative of u with respect to x, which is multiplied with v. What you will do, you will first write derivative of u with respect to x, which is multiplied with v. Then you will put a negative sign, that is, you will subtract. What will you subtract? You will subtract derivative of denominator v, which is multiplied with u. And then whole thing you divide by v square. You divide by the denominator square, making sure that v square is not equal to 0 because in denominator, it is in denominator. Okay. So let me write this once again. I will write this once again for you. Check. What have we done? The numerator has two terms. The numerator has two terms. What are those two terms? One term is u derivative of, one term is v derivative of u, and the other is u derivative of v. Okay. Remember, students, between these two terms, you have a negative sign. you don't have a positive sign, you have a negative sign. Okay, now because you have a negative sign here, it becomes very essential to know which term would come first. You cannot change the order. Remember, you cannot change the order. Okay, why I'm saying this? See, when you applied product rule, U into V, there you had plus sign in between. You had a plus sign in between. And because you had a plus sign in between, so it did not matter which term you write first. You write this or you write this. Okay, you can change their order of presence. It will hardly matter. What is important here in product rule? What is important? It is important that when you differentiate one function, you multiply the other and make sure that you have differentiated both the functions. And since there is a positive sign in between, you change the order, it does not matter. But then in quotient rule, it is important. You cannot change the order. Okay, now I repeat this once again. See here, you will always differentiate numerator first. See, derivative of u you have got d by dx of u. So you will make sure that in quotient rule, the derivative of numerator is written first and denominator multiplied. Then you will subtract this with derivative of denominator multiplied with u, the numerator, and denominator square. This is d by dx of u upon v, u upon v. Okay, I will write one more rule here. So here I will give you an example. Suppose I have d by dx of, e raised to x upon cos of x, e raised to x upon cos of x. So the rule says, what does rule says? The rule says always write derivative of numerator first. So I will have cos x multiplied to d by dx of e raised to x minus, it is a minus, then e raised to x d by dx of cos of x, and then cos x the whole square. Okay, cos x the whole square. Now what will happen next, students? I will have there, therefore d by dx of e raised to x upon cos of x, e raised to x upon cos of x is equal to, what is it equal to? It is cos of x e raised to x minus e raised to x minus of sine x. You know, d by dx of cos of x is minus sine x. d by
Yes,
dx
sir.
of e raised to x is e raised to x. And here you have cos square x. Then you will have plus sign here and take e raised to x common. E raised to x common. So you get cos of x plus sine of x upon cos square x. This is the final answer, d by dx of e raised to x upon cos of x. You can again replay the video and watch this. You can go back and you can watch this once again to understand better. Thank you. Hello students, we are doing the fifth theorem on derivative, that is d by dx of k multiplied to u. D by dx of k multiplied to u is k taken out and u differentiated with respect to x, where k is a constant. I will give you an example here. Suppose I have d by dx of 5 times sine x. Now what you notice? You notice that sine of x is a function of x. It depends on x. Sine of x depends on x. It is function of x. But 5, which is multiplied to sine x, it has no x in this. It has no x. It is like k. It is independent of x. I repeat again. It is independent of x. But sine of x is dependent on x. It's a function of x and 5 is constant. So what you will do next? Very simple. We will take 5 out and differentiate sine of x. So you will get here 5 times cos x, which is the derivative of 5 sine x. So now we will start solving few problems, students. Having done this, we can now start solving few problems. So to begin with, the first one I take is, differentiate the following with respect to x. Differentiate the following with respect to x. So we have here y, first one, y equals to x raised to 4 by 3 plus e raised to x minus sine x. I have to differentiate this with respect to x. So this is the given function of x. I have to differentiate this given function of x with respect to x. See, this is f of x. This is f of x, y equal to f of x. What I will do, I will write differentiating, I will write here differentiating both sides with respect to x. So when you write differentiating both sides with respect to x, what you do is you have y on the left hand side, so you write d by dx of y, and you have this thing on the right hand side, so you write d by dx of x raised to 4 by 3 plus e raised to x minus sine of x. Then what you do, you have these functions of x added and subtracted, so you write separate derivative. You write d by dx of x raised to 4 by 3 plus d by dx of e raised to x minus d by dx of sine of x. Okay, now the next thing you do is you have d by dx of x raised to 4 by 3. So you recall and recognize what kind of function is this. You have to name the function before you actually apply the result. This is mandatory. You have to make habit of doing this. Name the function, then only go ahead. Some students don't do it, and because of that, what happens is, right now they might be able to do it, but later when we have some composite functions of derivative, they start making mistakes. So I would suggest you that whenever you are differentiating a function of x with respect to x, make it sure that you name the function. So here the function is variable raised to constant, x raised to n. Here the function is constant raised to variable, e raised to x. Here the function is sine of x, And listen students, in all these functions, you will notice that the presence of x, variable raised to constant, variable is x, constant raised to variable is x, sine of x, sine of the variable is x, and you are differentiating with respect to x. Now, having done this, I will apply the result. This is x raised to n. It is 4 by 3, x raised to 4 by 3 minus 1. X raised to n, d by dx of x raised to n is n x raised to n minus 1 plus e raised to x minus cos of x. So here I have 4 by 3 and x raised to this. So x raised to 1 by 3. 4 by 3 minus 1 is 1 by 3 plus e raised to x minus cos x. This is dy by dx or d by dx of y. This is how you differentiate. Okay. So here we take one more example. This is number 5 from the textbook. I have here given y equals to 7 raised to x plus x raised to 7 minus 2 upon 3x root x. 7 raised to x plus x raised to 7 minus 2 upon 3x root x minus log of x plus 7 raised to 7. So as the question says, differentiate this with respect to x. So I write here differentiating. We can write even short form DIFF, it is allowed. Differentiating both sides with respect to x. WRT stands for with respect to x. So the next I write is d by dx of y. Here I have d by dx of 7 raised to x plus x raised to 7 minus 2 upon 3 x root x. See students, x root x. X into root x, I will write it as x into x raised to half. Root x is x raised to half. Square root is power 1 by 2. Then here I have x raised to 1. Now you know if the bases are same, the power gets added. So you have x raised to 1 plus half. And what is 1 plus half equals to 3 by 2. So this will finally get me x raised to 3 by 2. This is very important. Okay, I will write it this way. Why? Because I have to apply the result. I have to apply the result. Okay, you will know this in a short while. So 2 by 3 x root x, I will write x raised to 3 by 2. I have explained that how x root x becomes x raised to 3 by 2. Okay, minus log of x plus 7 raised to 7. Please don't go for calculation. How much is 7 raised to 7? That is not required. So the next step, what I do is I write separate derivative of all these. So d by dx of 7 raised to x, d by dx of x raised to 7, d by dx of this. I write derivative of all of these. Okay. So here I have d by dx of 7 raised to x plus d by dx of x raised to 7 minus d by dx of this. I will write now. I will write d by dx of 2 upon 3 d by dx of 2 upon 3 into x raised to 3 by 2. Okay. So when I write d by dx of this, remember students that 2 upon 3 is a constant multiplied to d by dx of 2 upon 3 into x raised to 3 by 2 is what I'm going to write it here. As I am writing derivative of all the terms, I would be writing derivative of this. So here I will get this one. But I notice that in this 2 upon 3 is a constant multiplied with x raised to 3 by 2. So the next step, this 2 upon 3 will come out. Okay. So here what I get is, I get next step as I will get 2 upon 3 out and d by dx of x raised to 3 by 2. X raised to 3 by 2. Okay. Minus d by dx of log of x minus d by dx of log of x plus d by dx of 7 raised to 7. So next step. Now we are going to apply the results. So here we have d by dx of 7 raised to x. As I told you students, every single time you are going to apply the derivative, you will name the function. Naming the function is very important, okay, because then only you understand which result you are applying. Okay, so here I have 7 raised to x. It is constant raised to variable. A raised to x, a raised to x, d by dx of a raised to x. What it was a raised to x log a. So 7 raised to x log of 7. Then this is d by dx of x raised to 7. The function is variable raised to constant, x raised to n type. Okay, so what I have, it is 7 x raised to 7 minus 1 6 minus 2 upon 3, and then you have d by dx of x raised to 3 by 2, which is 3 by 2 x raised to 3 by 2 minus 1, minus d by dx of log x is 1 upon x. And then here you have d by dx of a constant. 7 raised to 7 is a constant. What is d by dx of a constant? It is 0. Derivative of a constant is 0. So the next step, you have 7 raised to x log of 7 plus 7x raised to 6. This cancels. So here you have minus x raised to 3 by 2 minus 1 is x raised to half, which is root of x minus 1 upon x. This is dy by dx. You can again replay the video and check this. Okay, you can replay the video and check this. Okay, students, now we will have few questions where we have to apply product rule. So let's take this one. Question number 2 is once again differentiate the following with respect to x, and it's given, we are given y equals to x square plus 2 raised to 2 into sine x, So I will have to differentiate this with respect to x. I will have to differentiate this with respect to x. So I write here differentiating both sides with respect to x. So I get here d by dx of y equals to d by dx of x square plus 2 square into sine of x. And as you know, students, this is here we notice that we have product of two functions. Okay, you have product of two functions. So what are those two functions? Those two functions are, one is x square plus 2 the whole square. This is one function, variable raised to constant. The other function is sine of x. See, you can clearly distinguish between two functions. X square plus 2 the whole square is a variable raised to constant function which is multiplied to sine of x, sine function. So as the product rules suggest, how we will differentiate? Very simple. We will have to differentiate both one by one. When one of these is differentiated, the other one is simply multiplied. So I will write x square plus 2 square multiplied to derivative of sine x, then plus sine of x multiplied to d by dx of x square plus 2 the whole square. So next step. So here I have x square plus 2 square and d by dx of sine x. See students, this is derivative of sine x with respect to x. We know it is cos x. Okay. Sine function derivative is cos x, cos function. Then here I have sine of x. Okay, please see this. I have here a function which is, name the function, name this function. The function is variable raised to constant. Please observe this. The function is variable. See, this whole thing is variable. Yes. X is a variable. X square is a variable. In a variable, if I add 2, it becomes a variable. So it is variable raised to constant. This is function variable raised to constant. But the difficulty here we have is d by dx of x raised to n, I cannot apply here. I repeat again, I cannot apply d by dx of x raised to n here. Though this is variable raised to constant, same as x raised to n, I cannot apply. See, I could have applied if I had d by dx of x square. Check this. What I'm saying if I had this thing as x, d by dx of x square, if I had x square, I could have applied. But this is not, because when you have x square, then it is exactly in this form, x raised to n, and it is nx raised to n minus 1. This would have been 2x raised to 2 minus 1, that is 2 times of x. So what do? I cannot apply this result. I repeat again, if someone is thinking that d by dx of x square plus 2 square, variable raised to constant, we can write 2 times x square plus 2, 2 minus 1. Remember students, it is wrong. It is not correct. Later, after few lectures, I will teach you derivative of composite function, where we will take another composite function rule to differentiate this. Right now, what I'm saying is you cannot apply x raised to n here. You cannot apply x raised to n here. So what do? If I cannot apply x raised to n, then what is the method I should apply? Okay, see, I'll tell you that. What I will do is I will write d by dx, and x square plus 2 square, I expand this. This is, I apply the identity a plus b the whole square. So I get x square square, that is x raised to 4, plus 2ab, 2 times this into x square, that is 4x square, plus 2 square 4. Okay. Then next what I do is I write separate derivatives for all this. So I have here x square plus 2 square multiplied to cos of x plus sine of x, and d by dx of x raised to 4 plus d by dx of 4x square plus d by dx of 4. See students, sine x is outside, multiplied to derivative of this. Then what I did is I took d by dx in for all these functions. Okay, and I started with a bracket, because this sin x which is outside, it would be multiplied to each one of them. So in case if you forget to write this bracket, you commit a mistake. Okay, so the next step you write is d by dx of y equals to x square plus 2 square into cos x plus sine of x, then d by dx of d by dx of x raised to 4. This is x raised to n. Here you can apply. Why? Variable raised to constant and variable is x. Variable is x. You can apply here. So this is 4x raised to 4 minus 1, 3. Then you have here 4x square. I will take plus 4 is a constant. In 4x square, 4 is a constant, and d by dx of x square is 2x. Then you have d by dx of 4, which is 0. d by dx of 4 is 0. So the next step you have dy by dx equals to x square plus 2 square into cos x plus sine of x multiplied to 4x cube plus 8x. Derivative of 4 is 0. Here we wrote 0. Why? Because d by dx of a constant is 0. You can again replace this part and check. Thank you. Take one more question, students. This is second, fifth. And what we have to do is differentiate the given function with respect to x. The given function is y equals to x raised to 3 over 2 multiplied to e raised to x multiplied to log of x. So here I notice that I have three functions of x multiplied. Three different types of functions of x being multiplied. The first one I have is variable raised to constant. The second one I have is constant raised to variable, that is e raised to x. And the third one we have is logarithmic function log of x. They are all multiplied. So how we will do it? We have already done the product rule for product of three functions of x, d by dx of u v w. So here I write differentiating both sides with respect to x. So students, see what I will get. I will get d by dx of y equals to d by dx of x raised to 3 by 2 into e raised to x into log of x. So here I have x raised to 3 by 2 into e raised to, I know the product rule. The product rule says that you differentiate each one of them in order, and when you differentiate one of those, the rest two are simply multiplied. So I will differentiate log x first, multiply these two, then differentiate e raised to x, multiply these two, and then finally differentiate this, multiply these two. Okay, so what will I get? I will get here I will get here x raised to 3 by 2 into e raised to x d by dx of log of x plus, I differentiated log x, it is now turned, I differentiate e raised to x. So I will multiply x raised to 3 by 2 into log of x and d by dx of e raised to x plus, finally it is e raised to x multiplied with log of x and d by dx of x raised to 3 by 2. Okay. So I started from n2 first. Okay. N2 start. So this is x raised to 3 by 2 into e raised to x. You know, students, this is logarithmic function. D by dx of log x is 1 upon x. Plus this is x raised to 3 by 2 into log of x. And d by dx of e raised to x is e raised to x. Plus e raised to x log of x. And d by dx of x raised to 3 by 2 is 3 by 2 into the x raised to 3 by 2 minus 1, which is 1 by 2. Which is 1 by 2. So here, once again, the next step would be dy by dx equals to, see, this is 1 upon x and this is x raised to 3 by 2. As you know, this x has power 1. So when I take it up, it will become x raised to minus 1. When I will take this x raised to 1 up, this will become x raised to minus 1, which will get me x raised to 3 by 2 into x raised to minus 1. I'm just doing this two part. I'm just simplifying this with this. Okay. So here, what will the next step? It will be x power 3 by 2 minus 1. It will be, because the bases are same, so the power will be added. 3 by 2 minus 1, which is x raised to 1 by 2, you will get here. Okay, you will get x raised to 1 by 2. So I get here e raised to x. I get here e raised to x raised to 3 by 2 into x raised to minus 1, which is x raised to 1 by 2, plus x raised to 3 by 2 into log of x into e raised to x, the second term, plus e raised to x 3 by 2, I write the constant 3 by 2 out in the beginning for the term. 3 by 2 e raised to x log x and x raised to 1 by 2. What I can do is I can take x. Okay, see students, I can take e raised to x into x raised to half common. See, I have got x raised to half here, I have got x raised to half here. And remember that here in this term where you have x raised to 3 by 2, here also you have x raised to half. How? Because x raised to 3 by 2 is x into x raised to half. Remember, what is x raised to 3 by 2? It is x into x raised to half. X raised to 3 by 2 is x into x raised to half. So here I take e raised to x into x raised to half common. So I get here 1 plus x log x. From this x is left and e raised to x is gone, log x is left, plus 3 by 2 log of x. This is final answer. This is final answer. So one more thing you can write is, therefore dy by dx equals to e raised to x root x, e raised to x root x, x raised to half is root x, 1 plus x log x plus 3 by 2 log of x. This is the final answer.